Let's look at a few examples of applying the ratio and the root tests. So does the given series converge or diverge? So when looking at this series, I can go ahead and try the ratio test and see what happens on it. I see some powers of k. I can do the root test, but I'm going to lean towards ratios test, because doing the root test might nicely take care of this, and then having to deal with this with 1 over k, maybe I don't want to deal with that limit. So let's try the ratio test. So I'm going to look at the limit of the ratio of two successive terms, and that's going to answer, it's only asking convergence or divergence, but if I get something less than 1, it's going to converge even absolutely. Greater than 1 diverges, again a reminder, and 1 we can make no conclusion. So we're going to go plug in k plus 1s into all of these, and then divide by this a sub k term, which means multiply by the reciprocal. So I just have to do my algebra a little carefully when I do the ratio and the root tests. The rest doesn't seem to be that bad. So all I did was split the numerator into these two pieces and clean up the denominator a little bit. And we can get rid of the negatives also because we're taking absolute values, but I left them as they are. So it looks like these two guys completely go away. Let's clean up the powers of 4 a little bit. And when we split those powers up, 4 to the 2k and 4 to the 2k goes away. So now I'm up to here after my cancellations, and it looks like I can get rid of this 4 and a couple of those guys, or one of those as well, and leave me with a 4 squared. And now we know that both are linear terms in the numerator and denominator, so they have the same power, and all I have to worry about is the coefficients, which I guess gives me 5 over 8, and that is less than 1, so this series converges. All they asked was, does it converge or diverge? So I'm going to say converge, but we know that it actually converges absolutely. Okay, let's look at another one. Does this series converge or diverge? So if I just jump right into, let's say, the ratio test, because it ended up being easy, let's see what'll happen. So if I'm doing the ratio test, I have a sub n plus 1 divided by a sub n. Now I'm multiplying by the reciprocal of a sub n, and this is where I'm at. Let's go simplify a little bit. Of course, these just turn into positive 1s and go away, so I end up with numerator, a polynomial of degree 2. Denominator, when we multiply that out, FOIL it out, n squared plus 2n plus 1 plus another 1 gives me 2. All of these are positive anyway, so I don't necessarily need the absolute values. But notice I end up with the limit going to 1, same degree on top and bottom. And this is going to be inconclusive using the ratio test because the limit goes to 1. So anytime you have things like a polynomial over a polynomial, things that kind of look like a p-series, an adjusted version of it, the ratio and the root test won't work for you. They will end up being inconclusive. So we got to try something else here. So notice this is an alternating series, and since the question only asked for converge or diverge, it didn't say anything about absolutely. I don't necessarily have to go do an absolute convergence test. The ratio and root tests are nice because they automatically answer absolute convergence. But all I'm looking at is, does it converge or diverge? So I might as well just use the alternating series test. So I pull out my Bn, and when I pull out my Bn, it looks like definitely if I put n plus 1 in here, my denominator will be bigger than this denominator. So the first check for the alternating series test for Bn being decreasing all the time works. Next check is the limit as n goes to infinity, and that looks like it goes to 0. So that got qualified as well. So I can conclude that this series actually converges by AST. The alternating series test, of course. Okay, next example, does this series converge or diverge? I see that everything is raised to the power of n, and so I'm leaning towards the root test instead of the ratio test because I just want to knock off that power of n. So I'm leaning towards the root test because of that giant power of n enclosing everybody. If I take the nth root of the a sub n term and I get L, the same analysis as the ratio test occurs. Less than 1, of course, we said absolute convergence. Greater than 1 divergence, and 1 no conclusion. So let's go apply the root test here. So what happens here when I take the nth root of n, nicely these guys go away, and I just end up with the limit as n goes to infinity of this nice rational expression, same degree on top and bottom, so that's just going to be 4/7. Very easy limit analysis, and that's less than 1, so therefore this series converges by the root test. So everybody raised to the nth power, very nicely and quickly the root test knocks off that power. Let's look at another one. Does this series converge or diverge? Again, I see powers of n for both the numerator and denominator, so I'm leaning towards the root test. So I'm going to take the nth root of the nth term, a sub n. So all I really have is the nth root of the numerator and the nth root of the denominator, and I can do that by looking at it as a rational exponent if I want to as well. So the numerator will be raised to 1/n, and the denominator will be raised to 1/n. So we'll end up with limit as n goes to infinity of n to the 1/n just goes to 1, an absolute value of -2 is just 2. N to the 1/n, just again, n's cancel, and we end up with just 2/n, it looks like. And if I'm looking at the limit as n goes to infinity, I end up with 0. And the root test required us to be, the value of L to be less than 1, so this converges by the root test. Wasn't so bad. Okay, last one. Does this series converge or diverge? Well, again, I see a power of n involved here and some powers of n maybe in the denominator, so I'm going to lean towards the root test might be easier for this one. All the terms are positive anyway, so I'm just going to take the nth root of the entire chunk. So I'm going to take the nth root of the numerator, raising it to the 1/n, and the same thing with the denominator. So numerator n times 1/n is just 1. I end up with n to the 1. Denominator I'm going to split up using exponent laws, and then have each one of these items, since it's a product, share that exponent of 1/n. So I've got n over 3 to the 1/n for the first guy, and then 1/n and n cancel each other out, 3 squared for the second guy. So now as n goes to infinity, this piece is going to go to the 3 to the 1/infinity, so 3 to the 1/infinity goes 3 to the 0, goes to 1. So this piece just goes to 1 if I'm looking at the limit as n goes to infinity. But this thing blows up, so it looks like the limit of this thing goes to infinity. And since it blows up, goes to infinity, and is bigger than 1, we can say that this guy diverges by the root test. Let's actually quickly look at a couple more. Does this series converge or diverge? Since I see factorials involved, I'm going to lean towards the ratio test. As we said in class, the ratio test is easier normally when you see factorials. They're all positive, so I've left off the absolute values, evaluated at n plus 1, divided by the a sub nth term, multiplied by the reciprocal. Let's clean these guys up a little bit. So we'll multiply out that binomial and get that power, strip out one of the terms of the factorial, and put it in terms of n factorial, so these guys can go away. Now we can use exponent loss and split up this term, and looks like some other item is going to go away as well, so these guys will go away. So here's where I'm at, and I need to evaluate this limit. I have a 2 times 2 to the 2n. Maybe I can actually write that as 2 times 2 squared to the n. I don't have to do that, but that might make it easier on the eye. 2 squared to the n is actually multiply the powers 2 to the 2n. So now I have 4 to the n, and it looks like when I try to evaluate it, I get infinity over infinity. So let's apply L'Hopital, and we're going to have limit as n goes to infinity. I can pull out the 2 outside if I want to, it's just a constant. Derivative of the top is 4 to the n times ln of 4. Derivative of the bottom is just 1, and it looks like when I take the limit of this guy as n goes to infinity, it actually blows up. So this thing diverges by the ratio test. And again, ratio test was easier here because we saw the factorial. Just had to do a little bit of algebra, that's all. Now again, looking at this and analyzing the limit, or analyzing whether the series converges or diverges, I see a power of n raised, so I'm going to lean towards the root test to knock off that power. So we'll take the nth root of that guy, and nicely the nth root of 1 over n multiplied by 5n will get rid of that n that I didn't want. So it looks like now all I have to do is raise that item to the 5th power, and everything is going to become positive since I'm looking at it in absolute values. So now I got limit as n goes to infinity of 32. I've got n to the 5th, and down here too I'm going to have n to the 5th plus some other terms, so same degree on top and bottom. That means the limit goes to 32, and since this is less than 1, this thing is going to diverge by the root test this time. So all we did in this video was basically just apply the ratio and the root tests, kind of eyeballing and seeing which one would be easier to use.